Good evening to you all.
Good evening, ma'am.
Good evening, ma'am.
My slides are visible.
Yes, ma'am.
So the last class, we look at independent and the dependent events, right? So if two events A and B are said to be independent, if probability of A given B equals PA or probability of B given A equals PB. This is the rule we are using to test whether two events A and B are independent, right? If A given B not equal to probability of A or probability of B given A not equal to probability of B, these two events are dependent, right? And also you have to remember that independent events and the mutually exclusive events are different. They are not the same meaning. Mutually exclusive means both events occurred at the same time, but independent events, the occurrence of one event does not affect the occurrence of the other event. This is the difference between the independent events and the mutually exclusive events. Then we look at the marginal probabilities. When we are adding row-wise or column-wise, these probabilities are called marginal probabilities. And the cell probability, for example, this is called a joint probability, right? These 0.4, 0.6 are marginal probabilities. Similarly, in the column-wise, 0.17 and 0.3, both are marginal probabilities. When you are adding the marginal probabilities row-wise, or when you are adding the marginal probabilities column-wise, you will get the total probability as 1. And from that also we look at those two probabilities, and from this we find out probability of B1 and B1 and A1 are not independent events. Right. Now today we will take this exercise and we will check the answers. Right. So here companies' employees have been classified according to age, salary, as shown in the table. In the age, there are 3 categories: under 30, 30 to 45, and over 45. Similarly, the salaries also has 3 categories: under 25,000 salary, and between 25,000 and 45,000, and over 45,000. Right? And how many in each of every category, how many respondents are there? Right? So here one employee is selected at random, and the 2 events are defined as follows. Event A, the employee is under 30, and event B, the employee salary is under 25,000. Now you have to find the probabilities. So probability of A given B, right? So according to the conditional probability definition, probability of A given B, we can write as a probability of A intersection B divided by probability of B. Now we look at what's A and B. A means the employee is under 30, and B means the employee salary is 25,000. So here altogether, this is under 30 and 25, this is. Then out of how many total employees are there? Anyone? How many total employees? Answer, anyone? How many total employees?
100, ma'am.
Right, 100, right? So the probability of A intersection means the employee is under 30 and also he has got an income as under 25,000 as a salary. So the probability is 32 over 100 divided by probability of B. That means the probability that the employee salary is under 25,000. So how many employees are getting salary under 25,000? 42, 43, right? 43 employees are. You have to add all these three facts. Right? So 32 plus 30 plus 1. So that is 43 divided 100. So your probability is 32 over 43. Right? Then second part, B part. This is A. B, probability of B given A. Probability of B given A. That is also probability of A intersection B divided by probability of A. But probability of A intersection B already we calculated. That is 32 divided by 100 divided by probability of A. The employees under 30. So there are altogether employees under 30, 32 plus 3 plus 0, that is 35. That is a marginal probability, right? Marginal probability of first row. That is 35 divided by 100. So that is equal to 32 over 35. Right? Part C. So what does this numbers means? Probability of A given B 32 over 43. What does this number tells? The probability that the selected employees, given that the selected employees are under 25,000, the probability that the employee is under 30 is 32 over 43. Right? So similarly, probability of B given A, the likelihood of being a selected employee under 30 with salary is under 25,000 is 32 over 25. Right? Then for part C, probability of A given B complement, that is probability of A intersection B complement divided by probability of B complement. Right? So what does B complement means? B is in the employee salary is under 25,000. So the B complement employee salary is over 25,000. 25,000 and over 25,000. So this amount will come. This is actually B. All these numbers are belonging to B complement. Right? Because B is employee salary is under 25,000. So B complement the salary over 25,000 or over 25,000. Right? Then A intersection B complement, that means A is under 30 and B complement these two things. Salary should be intersection. A is these 3 and 0. These both are under 30. Sorry. Yes, the employees under 30. These three cases. So here, these two cases are A intersection complement, B complement, right? So from this one, that is 3/100 divided by B complement. If we add all these three things, that will, I think, 57 altogether. 57/100. So that is 3/57. Right? Similarly, you can calculate probability of A given intersection. That is, I am leaving as a whole. Right? To find out this value. So this is by using, now we learned that this is also like a relative frequency approach, but here two variables related, right? Two distributions are related. One is age and the salary. So this type of distribution is called a contingency table. So from this, now we learn how we can calculate the probabilities, right? Another application here, there is a personnel department of an insurance company has compiled data regarding the promotion and the classified by gender, right? So the managers, they are classified by male or female, and also the managers promoted or not promoted. Now they want to look at is promotion and gender dependent on one another. That means whether male have more chance or female have more chance to be promoted, right? That means whether the promotion is depending on the gender. We have to find out whether the promotion is depending on gender. So this is like a conditional probability. If the selected person is male, then what is his promotion, right? So now first we will calculate that one. So here we put the notations. P is a promotion, getting promotion, promoted. And for male, we are giving M denotes male, F denotes female. Right, so here, first we will take probability of promotion given that male. If the selected employee is male, then what is the probability of getting promoted, to be promoted, right? So here also it's a conditional probability, that is probability of P intersection M divided by probability of being a male. So probability of promotion and male, how many promoted? There are 46 males, they got promotion, right? So that is 46/270. The promoted male, right? 46/270. And the selected employee is male. There is a male altogether 230 divided by 270. That is 46/230. Right? Now also we find out that what is the probability of getting promotion. If any employee selected, what is the probability to be promoted? So probability of the selected employee being promoted, right? So how many employees promoted altogether, whether it's a male or female, that doesn't matter. There are 54 employees promoted out of 270. right? So now if we look at this one, probability of, from this, probability of, if male is selected and the promotion for the probability 46 over 230. That is actually 23 over 115, right? And for the selected employee manager promoted, 27 over. If we're looking at these two, when you are comparing these two, we know that probability of P given M not equal to probability of P. Right? The per selected employee is promoted is not equal to if a male is selected and he got the promotion, both are not equal. So the promotion from this one, we can say that the promotion is not is depending on the gender. Promotion is depending on gender. This is one way. Otherwise, you can find out that this is one method, whether these two are independent or dependent. So here, gender affects the promotion because both probabilities are different. Otherwise, you can find out that similarly, what is the probability if the selected manager is female, what is the probability to get promotion? That is also we can calculate. Writing here. So probability, if female manager is selected, then to be promoted, given F. So that is also, there is 8 females only promoted, 8 over 270. This is also both female and male. This is not equal to probability of P given male. From this also we can say that the promotion and gender is dependent on one another, right? The promotion is depending on the gender, right? Now we are looking at some probability rules. There are 3 rules we will learn. One is the complement rule, a multiplication rule, and the addition rule. Here what we are doing, more than one events we are making the joint, and then we are looking at the probabilities, how we can calculate, right? Already we learned that from the random experiment, how we can calculate the probabilities for the simple outcomes. Right? By each and every one, there are 2 methods we learn to assign the probabilities. One is the classical approach and the other one is the relative frequency approach. By using one of the 2 rules, we can assign the probability for the outcomes we obtain from the random experiment. Then we made the events using the outcomes, right? Using the outcomes, we made the events. From that also, we can calculate the probabilities by adding the probabilities of the appropriate outcomes. Then when we are making some events, right? Combining some events using the simple outcomes or using the events which are made of the simple outcomes, then there are some rules to calculate the probabilities. These are called as a complex events, right? So first we will learn about the complement of an event, right? Already we learned that complement is the outcomes which are not belonging to the particular event, then that event is called the complement event, right? So for that, the probability is calculated by using this formula. If we know A, then we can calculate the probability of A. And then from this one, we can calculate the probability of A complement, that is 1 minus probability of A. Then multiplication rule is used to calculate the joint probability of the two events. It is based on the formula for conditional probability, right? The conditional probability formula we define probability of A given B equals probability of A intersection B over probability of B. So the joint probability is A and B. When we are combining the events A and B, if there are common elements, then that is called a joint event, right? So accordingly, the joint probability of A given B, this is called as a joint probability. That is by cross multiplication, probability of A intersection B is equal to probability of A given B into probability of B. In other way around also, we can calculate a probability of A intersection B is equal to probability of B given A into probability of PA. Right? These two formulas, whatever events first occurred, accordingly, we can calculate the joint probabilities. Then if A and B are independent events, right? Remember that if A and B are independent, then probability of A intersection B is equal to probability of A into probability of B. Right? If both are independent, because if independent, in this case, probability of A given B is equal to probability of A. So that is probability A into probability of B. Similarly, if A and B are independent, then probability of B given A is equal to probability of B. So when we are multiplying, this becomes probability of B. That is probability of A into probability of B. Right. Now here a simple example to applying this joint probability we are having. A graduate statistics course has 7 male and 3 female students, right? For a graduate statistics course, there are 7 male students and 3 female students. Altogether, there are 10 students are taking the graduate statistics course. The professor wants to select 2 students at random. Out of 10, he or she wants to select 2 students at random to help her to conduct a research project. So what is the probability that the 2 students are female? So here actually they want to calculate the joint probability, right? So here we are taking this as a male, student being male and student being female. So now we want to calculate both students are female. So the selected both students are female. So that is probability of F. First selection also female and the second selection also female. F and F. First also female and the second selection also female. So here you can write this as a probability of F, first selection, into the second selection. If the first is female, then what is the probability of selecting second also female? This probability we have to calculate, right? So what is the probability of first student being female? There are 3 female students. So 3 over 10, selecting a first 10. And if F is selected, first is selected as a female, then there is only, now from this, for the second selection, there is only 2 students are there. Now 2 female. So that is 2 into, now the total is 9. 2 over 9. So that is equal to 6 over 90. Okay. So the probability, that's the selected 2 students per female are 6 over 9. So So this is one of the example to calculate the joint probability, right? Now we are coming to the addition rule. It's provide a method to compute the probability event A or B or both A and B occurring. That is, we want to calculate the probability of A and B. Either one of the event, if you want to calculate the probability for either one of the event occur, then we have to calculate probability of A or B. That is, it's actually denoted by probability of A union B. This is same as A union B, right? And we are using the notation intersection, or we are using the notation union. Right? So that is given by the probability of A plus probability of B minus probability of A intersection B. If A and B are mutually exclusive events, if A and B are mutually exclusive events, that means there is no any common element for both A and B. If A and B are mutually, both events not occur at the same time, right? So if both events are not occurring at the same times, that means there is no any common element for both A and B. So if there is no element in the common, then probability of A intersection B equals 0. Right? So if A and B are mutually exclusive, the occurrence of one event makes the other one impossible. So this means that probability of A intersection B equals 0. So if finally, if A and B are mutually, then the addition rule becomes probability of A union B equals probability of A plus probability of B. Right? This says as a, so the addition rule, there are two addition rules we are using. If A and B are not mutually exclusive, then this is the common formula you have to use. Right? If A and B are mutually exclusive, then this rule we have to use. When A and B are mutually exclusive, A intersection B is a null set. So that is, the probability is 0. Right. Now here we are looking at an example. In a large city, 2 newspapers are published. One is Sun and the other one is Post. The circulation departments report that 22% of the city's households have a subscription to the Sun. Right? For the 22% of the city's households are subscribing to the Sun, and 35% are subscribing to the Post. A survey also reveals that 6% of all households subscribe to both newspapers. So what proportion of city's household subscribe to either newspaper? So now we are defining the events. S is subscribing Sun. Defining the events, subscribers of Sun. Right, P, subscribers for Post. These are two different magazines. Now we want to calculate the proportion. What proportion of the city's households subscribe to either newspaper? So here they are asking, according to this question, we want to calculate S union P. Right? So according to the addition rule, we know that it is equal to probability of S plus probability of P minus probability of S intersection P. Right? So probability of S means How many percentage are subscribing for Sun? 22%. Right, so 0.22. What percentage of people subscribing for Post? That is 35%. 0.35. What proportion of people, household subscribing for both newspapers? That is 6%. 0.06. So from this we calculate 0.51. So that means 51% of the household subscribing either newspaper. Either it may be Sun or it may be Post or both. Right? So 51% of the households are subscribing either of a newspaper. Right? That is the interpretation of this example. Right, okay. Now we are moving to the next slide. This is also one of the applications for the business side. Regarding the fund and the mutual fund and their contributions from the investors, right? So a stock market analyst finds that the probability that a certain mutual fund will receive increased contribution from the investors is 0.6. Probability of getting increased contributions from the investors for a certain mutual fund is 0.6. This is one information you have. Then the probability of receiving increased contribution from investors becomes 0.9 if the stock market goes up. So here two events are mixing. Here also we are receiving the increased contribution like in the first statement, but there is a condition. If the stock market goes up, the stock market rises, then the increased contribution from the investors to receive is 0.9. Right? The probability of receiving increased contribution from investors drops below 0.6 if the stock market drops. But we don't know the exact probability. Anyway, if the stock market dropping, then receiving increased contribution, the probability of receiving increased contribution from investors drops below 0.6. And also there is a probability of 0.5 that stock market rises. So the chance of stock market rising is 0.5. There are three main probabilities given here, right? And also they define events of interest. A, the stock market rising. B, the company receives increased contribution. So A is a stock market rising. So from this one, we can know that probability of A, because here they gave the probability of 0.5 that the stock market rises. So probability of A, they gave as 0.5. Then the company receives increased contribution. That is probability of B. Without any condition, the probability that company receives increased contribution is 0.6. In addition to that one, we also know that if the stock market goes up, then to receive increased contribution, so receiving increased contribution is denoted by B given A. Right? A is stock market rising. That is also we have 0.9. So now the probability the two probabilities we have to calculate. The probability, there is a sharp increase in earnings. If there should be this is logically you have to think about, right? They've asked to calculate the probability that sharp increase in the earning. So if a sharp increase, there is a sharp increase in earning, the stock market also should be rise and the company also receive increased contribution, right? That is a sharp increase. Both should occur at the same time, A intersection B. There should be a receive increased contribution also should be there, and stock market also rising. If both happen at the same time, then there should be a sharp increase. Right? This is you have to think about, right? What does the sharp increase mean? Sharp increase should be occur when stock market also rising and also the company receiving increased contribution. So this is actually probability of joint probability B given A into probability of A. So what is probability of B given A? 0.9 into probability of A 0.5. That is 0.5. So to get sharp increase in earning, there is a 45% of chance, right? That is 45%. Right? So there is a 45% of chance that there should be a sharp increase in earnings. So sharp increase occurred when both events happen. Rise, there is a receiving increased contribution and also stock market also rising, right? Then the second probability they are asking, a probability that is at least moderate increase in the earning. So either one of should occur, right? So probability of at least moderate increase. So that means probability of A union B. If we will get the moderate increase, either there should be a increased contribution or there should be a stock market rising. Either one of the event happen, then there should be a moderate increase, at least moderate increase we can get. If you want to get sharp, both events should occur. If we want to get the moderate, then at least one of the events should occur. So that is additional rule. By using the addition rule, probability of A plus probability of B minus probability of A intersection. So that is equal to probability of A 0.5 plus probability of B 0.6 minus probability of A intersection B 0.45. So this is equal to 0.65. Right. So now, based on this given statements, you have to identify what does the sharp increase mean and what does the moderate increase. So sharp increase, both events should occur at the same time. For moderate, either one of the event should occur. Stock market rising or receiving increased contribution, right? So this is one of the workplace applications by using calculating the likelihood of occurring the events, right? Right. Now we are coming to the next slide. Another method for calculating the joint probabilities by using the probability trees or tree diagram. The tree diagram, when we can apply the tree diagram, more than one activities occurred, then we can use the tree diagram. Right? So how here the same example, earlier we take here a graduate statistics course has 7 male and 3 female students. The professor wants to select 2 students. So 2 activities, 2 times the same thing repeated at random to help her to conduct a research project. So what is the probability that the 2 students chosen are female? So now here we have the 2 branches because either female, in the first selection, female may be selected or male may be selected. So for the female selected, 3/10. If the male is selected, 7/10. Then, and second time also, the female may be selected or male may be selected. But in this branch, it's depending on the first selection. So if female is selected in the first, then what is the probability of selecting a female again? That is 2/9, right? If female is selected first and in the second time, if male is selected, that is 7/9 because there is another, in this case, there is no any male selection. So 7/, total 9 students are there for the second selection. Similarly, if the first selection, male is selected, then in the second selection, for the female selection, 3/9. But if the male is selected first, in the second time also male selected, then 6/9. So here, these are the conditional probabilities. These branches have conditional probability depending on the first selection, right? Then to the joint probability, if both are females, you have to multiply these 2 branches probabilities, right? 3/10 into 2/9, right? For when we are multiplying these 2 cases, this will give female and male. First selection female and the second selection male, 3/10 into 7/9. Then for this branch, the joint probability is both are first male and second female, that is 7/10 into 3/9. Here, first is male and the second is male, 7/10 and 6/9. When you are adding all the joint probabilities, then you will get the total probability as 1. When you are adding all the joint probabilities, the total probability will be 1. Right? So this is the joint probabilities, how we look at how we calculate the joint probabilities, right? At the ends of the branches, we calculate the joint probabilities as the product of individual probabilities on the preceding branches. So how we are writing the joint probability? FF. So that means F intersection F. Both are females. This means both are females. This means female and male. First is female and second is male. This probability means first is male and second is female. This is both selections are males. Right? Now we are coming to the simple example, applying the tree diagram. Law school graduates must pass a bar exam. This is like a on job time. They are having some exams for promotions. That is called a bar exam. So suppose the pass rate for the first time test is take a 72%, right? Only the 72% are passing in the first time when they are taking the bar exam. If they fail, then they can rewrite the exam. And when they are rewriting the exam, 88% chance is there for the second attempt. So, what is the probability that randomly graduate passes the bar exam? So, here we will put this information in a tree diagram and then we look at it, right? Right. So, here also 2 times they are taking the exam, right? So, the second time is, pass rate on the second time is depending on the first exam, right? So, it is a exam results. It is pass or fail. For the first time, this is first time. What is the probability of passing the bar exam in the first time? 72%. That is 0.72. So in the first case, the failure probability is 0.28. 1 minus 0.72, 0.28. Then second time. The second time, there is no chance. This branch does not work because they all pass the exams. So if these candidates are passed the exam, then they will not take the exam second time. So there is no branch. But here, there is a branch. For the second time, only the candidates who failed the exam take the exam second time. So it is pass, fail. Then what is the rate of second time? If they fail the exam first time, then the pass rate is 0.88. So this means 0.1. So here, this is joint probabilities. Here we are calculating. This is only probability of pass the exam. That is 0.72. Here, probability of first time fail and the second time pass. Right? That is 0.28 into 0.88. For this branch, both times fail. Fail intersection. Fail. That is 0.28 into 0.1. So actually, what is this probability? This is a conditional probability, right? This equal actually probability of pass the exam if fail in the first time. This is also conditional probability. Probability of fail the exam second time if fail in the first time. Right? So now here, what is the probability they ask? What is the probability that randomly graduate passes the bar exam? So probability of passing bar exam. Here there are two cases. They can pass the exam in the first time, or they can pass the exam in the second time. So that is F intersection. There are two cases to pass the exam. This is one case. And here also they pass the exam. Right? So the first time, what is the probability to pass the exam? 0.72 plus